All right, we're going to jump into lesson 14.3. This is a continuation of the 14.2/14.3 video. This is part 2. We're going to look at exponential growth and decay. This is just going to be kind of an introduction here. And so first I want to just bring your attention to the standard form of our exponential functions here, which is listed as y equals a times b to the x. And so we've got a couple of variables here that we're going to talk about when we talk about exponential growth or decay. So first, just like our geometric sequences, the key here is that for exponential growth or decay, we have a common multiplier, right? So instead of adding a number over or subtracting a number over and over again, we're multiplying by a number over and over again. And so if we look at our variables here, we've got a, and a is going to be our initial value. Our initial value, and this is also going to be our y-intercept, right? That's the same thing as the initial value. And then for b is going to be our common ratio, as we've seen with the geometric sequences, or we can also call it our multiplier. So it's the number that we're multiplying by over and over and over again, okay? And as we get into these types of functions and these types of graphs, I want to remind you of some properties of exponents. Maybe you've seen these before, maybe you haven't, but if you haven't, we'll introduce them right now. And the first one is if we have negative exponents, because notice here that our variable x is in the exponent here, right? This is an exponent. So our variable x is in the exponent, which means sometimes we're going to get negative exponent values. And so the rule for negative exponent values is that it's going to flip our fraction, but it doesn't make the number negative. So check out what I'm talking about here in this first one. Okay, we've got 1/2 to the negative 2 power, right? And so what happens is it flips my fraction. So now 2 is on top, 1 is on the bottom. Okay? And because the exponent was 2, we have 2 squared, and we have 1 squared. All right, so it flipped my fraction, but it didn't make anything negative. We can do the same thing on the second one here, right? The one that's in green. We've got 3 to the negative 2 power. Remember, the number 3, that's the same thing as 3 over 1, right? And since it's a negative exponent, it's going to flip my fraction, so it becomes 1 over 3, and then it's just squared and squared because the exponent here was 2. So if we have a negative exponent, that flips my fraction. And we'll look at that a little bit more in the next couple problems. And then also I want to bring your attention to the next piece here, which is that anything raised to the 0 power is equal to 1. So for example, if I have 5 raised to the 0 power, that equals 1. Okay, and that's so that our number system works, and we'll talk a little bit more about that as we get into more properties of exponents here. So anything to the 0 power equals 1. Let's check out a couple of these problems here. So they're just going to get started by giving you a domain. Remember, these are the x values. Remember, domain is the x values, and then they're going to have you plug them into the function. We can see this is an exponential function because first, x is in the exponent, so this is going to be an exponential function. Okay, and so it's going to be either a growth function or a decay function, and that's all determined on what the b value is here. All right, since my b value is greater than 1, this will be a growth function. And we'll look at that in the next lesson here. But for now, we're just going to go ahead and make a table and plug these values in. So I've got x, and I've got y. Domain is the x's, remember, so they gave me those -2, -1, 0, 1, and 2. And I'm just going to plug these things in one by one here. So first, I'm going to find f of -2. So that's going to be 1/2 times 2 to the -2 power. All right, and so just kind of watch the process that I take to solve these problems because we have to use PEMDAS. We also have to pay attention to the negative exponent. So it's going to look like this. 1/2 times, well, remember we said if we have a negative exponent, that's going to flip this fraction, right? So this is really like a 2 over 1. So I'm going to make it 1 over 2, and that's 1 squared and 2 squared, because that's what my exponent is above. And so now I'm going to evaluate that part. So I have 1/2 times, well, 1 squared is 1, and 2 squared is 4. And so now I'm going to multiply these fractions again, and we get f of negative 2. It's 1 over an 8. Okay. So one more time here, when we have negative exponents, that's going to flip my fraction. So instead of 2 over 1, I now have 1 over 2. And since this was a 2 here, they both get that exponent there, and then I evaluated. That's the first one there. Let's look at the next number. This time I'm looking for f of negative 1. So we'll go ahead and plug that in here. I'm going to have 1/2 times 2 to the negative 1 power. Okay, so we got a negative exponent. So once again, I'm going to have to flip that. Instead of 2 over 1, I'm going to make this 1 over 2. And this time the exponents are just 1s there because we have a negative 1 as the original exponent. And so then we end up here with 1/2 times 1 to the first is 1, 2 to the first power is still 2, and so we have f of negative 1 equals 1 times 1 on the top is 1, 2 times 2 on the bottom is 4, so 1/4. Okay, and we'll keep it going here. Those ones take up a lot of space because I wanted to go through all the steps here, right? You can speed this up and probably take up less space if you wanted to. So let's keep going. Kind of box these up so we don't get confused. All right, next I'm going to find f of 0. So we're going to do f of 0, so that means I'm going to plug in 0 here. So I get 1/2 times 2 to the 0 power. Well, remember we said that anything to the 0 power is 1, so that's going to turn into 1/2 times 1, which is just 1/2. Okay, and so once again, that's because anything to the 0 power is 1. Okay, so I just replace that with a 1 and I'm good to go. Okay, and then we move to the last couple here. We need f of 1. So this is going to be 1/2 times 2 to the first, which is the same thing as 1/2 times, well, 2 to the first power is just 2. Notice I don't have to flip this one, right, because it's a positive exponent, so I don't have to flip it. I only have to flip it with negative exponents. And then we know that 1/2 times 2 is just 1. And then lastly here, we're going to find f of 2. And so we've got f of 2 is going to be 1/2 times 2 squared, which is 1/2 times, well, let's see, 2 squared is 4, and then 1/2 times 4 is 2. And so we have our table there, right? And now I'm just going to plot each one of these points onto our graph. So the first one from up top on the table is -2, 1/8. So that's going to be -2 and then just barely off the line there. Next we have -1, 1/4. So that's going to be same deal, just a little bit higher. Then we have 0, 1/2. So that's just going to be right in the middle there. Then we have 1, 1. And then we have 2, 2. Okay, and so what we're going to see happen here is that these graphs are going to tend to take this shape where they're curving either upwards or downwards, like this. And there's a thing called an asymptote here, which is kind of like an imaginary border. And we'll talk about why that exists in a later lesson. All right. Move to the next one here. Okay, same idea. We've got our table that we're going to make. So x and y, our domain value, -2, -1, 0, 1, and 2. Okay. And then we're going to go ahead and punch these numbers in. So we'll go ahead and do that. So I'm going to punch in -2 first. So it's going to look like this. F of -2 equals, let's see, that's going to be 8 times 1/2 to the -2 power. Okay, remember we said with negative exponents, they're going to flip my fraction. So this is going to look like this, becomes 8 times, flip this to 2 over 1, right? Flipped it upside down. Okay, and then we keep going here. So we get 8. This is going to become 4 over 1, which is just 4, of course. And so then I end up with 8 times 4, which is 32. Okay, and so I got 32 there. And then we'll keep going here. Okay. Next, we're going to plug in -1. So I'm going to go ahead and find f of -1. So we'll punch that in there. So it looks like this. F of -1. I'm going to end up with 8 times 1/2 to the -1 power. All right, well, we've got a negative exponent, so that means I'm going to have to go ahead and flip that fraction. So I get 8 times, instead of 1 over 2, it's now 2 over 1 to the first powers. Well, that just gives me 8 times 2, and that just gives me 16. Right, notice I don't really need this 1 that's on the bottom, right? That's why I'm kind of ignoring, because we're dividing by 1, so that's why I'm not using it for anything. We'll keep going here. F of 0. So now I'm punching in 0 for x. So we're going to end up with 8 times 1/2 to the 0 power. Remember, we said anything to the 0 power is 1, even if it's a fraction. So I get 8 times 1, and that just gives me 8. So I'll add that to my table. We'll keep going here. Now we'll find f of 1. So that's going to be 8 times 1/2 to the first power. So that's just the same thing as 8 times 1 to the first and 2 to the first, almost like we're distributing that 1, right? That exponent there. And so then that just becomes 8 times 1/2, which becomes 4. And then next we're going to find f of 2. So we get 8 times 1/2 squared. Notice these aren't negative exponents, so I don't need to flip my fraction. I'm just going to make it 1 squared over 2 squared. So I get 8 times 1 over 4, and 8 times 1/4 is 2. And so once again, I'm going to put this on my table here. Notice some of these are going to fly off my graph because the numbers are too big, but we'll just kind of estimate. So the first one is -2, 32. So that's going to be like way up here, -2, 32 off the graph. And then -116, same deal, right? Somewhere up here, way off the graph. Then we have 0, 8. Then we have 1, 4. And then we have 2, 2. And so this is going to take a similar shape, except it's going to be kind of like a ramp going downwards. So it's going to look something like this as we graph it, where it has that imaginary border. It doesn't cross that x-axis because there's this imaginary border called an asymptote there, and we'll look at that a little bit deeper at a later lesson. All right. Okay, thanks for watching.